All right, today we're going to talk about the composite design pattern. It's this really clever way that developers can handle complex, tree-like structures with, honestly, a surprising amount of elegance. And it's all based on one simple idea. What if you could treat a group of objects in the exact same way you treat a single one? So let's just jump right in with a classic problem. Imagine you're building some kind of e-commerce system. An order comes in. It's got individual products, sure, but it also has boxes. And what's inside those boxes? Well, maybe more products, or maybe even smaller boxes, which have their own items inside. So how in the world do you calculate the total price of all that? What you end up with is this nested structure that programmers call a part-whole hierarchy. It looks a lot like an upside-down tree. Now, if you try to just write a simple loop to go through everything, it gets incredibly complicated really fast. You'd have to constantly be checking, am I looking at a product or is this a box? If it's a box, I need to look inside. It just becomes a total mess. And this is exactly where the composite pattern comes in to save the day. It gives you a unified, elegant way to handle these nested structures without writing all that messy code that's constantly asking, what kind of thing am I?
The core idea here is actually pretty simple, but it is incredibly powerful. The pattern basically establishes a common language, or what we call an interface, for every single object in the tree. And this means that whether your code is dealing with a single little product or a gigantic box full of other stuff, it can treat them in exactly the same way.
And this is where the real magic happens. You don't have to write some complicated logic. You just ask the top-level order, hey, what's your total price? If that order contains a simple product, great, it just gets the price. But if it contains a box, the box just turns around and asks all of its contents for their prices and adds them all up. The request just flows down the tree, completely automatically.
So how does this actually work under the hood? Well, the pattern really relies on three key players that all have to work together perfectly. Everything, and I mean everything, starts with the component. You can think of this as the rulebook. It's an interface that lays out all the common operations for everything in the tree. So in our ordering system example, it would define a method like getPrice. This ensures every single object, big or small, knows how to respond when you ask it for its price.
Now, using that common rulebook, we create two different kinds of objects. First, you have the leaf. This is our individual product. It doesn't have any children. It's the end of a branch. It does the real work, like providing its own specific price. Then you have the composite. This is our box. Its only job is to be a container, to hold other components and delegate tasks to them, like asking all its children, hey, what are your prices?
You know, a classic company org chart is a perfect real-world way to think about this. A single employee with no one reporting to them, that's a leaf. A manager who has a team of people under them, that's a composite. And the beauty is, you can ask for information from a single employee, or you can ask the entire department, and the request is handled in the exact same way. It just flows right through that hierarchy.
And believe me, this isn't just some abstract, theoretical idea. This pattern is actually used in tons of systems you probably interact with every single day.
For instance, think about a graphic design program. You've got your basic shapes, like circles and squares, those are the leaves. But then you can group them together to form a more complex shape. And that group is a composite. You can then move or resize the entire group just like you would a single shape. Same exact logic applies to your computer's file system, right? Files are the leaves, and directories are the composites that hold them.
Okay, so knowing what a pattern is one thing, but knowing exactly when you should and shouldn't use it, well, that's the real skill.
Let's really dig into that question by looking at a fantastic, really practical example from a developer who is trying to get their head around this very pattern.
So this developer was building a basketball statistics app and asked if this pattern would be a good fit. And, at first glance, it seems perfect. You've got players, those are your leaves. You've got teams, which are composites made of players. And then you have leagues, which are composites made of teams. It's a perfect tree structure. But here's the catch. A team has stats like wins and losses, right? But an individual player doesn't really have wins and losses in the same way. And this exposes one of the key trade-offs of the pattern. To keep that universal interface, you might have to add methods to the rulebook that just don't make sense for a leaf. A player object might have to just return 0 for a getWins method, which can feel a little clunky.
And that really brings us to the core principle here. You should use the composite pattern when your #1 goal is to let the rest of your code be blissfully ignorant about whether it's dealing with one single object or a whole collection of them.
If that uniformity is your top priority, this pattern is an absolutely fantastic choice.
So let's quickly weigh the pros and cons. The biggest pro, by far, is simplicity. You can manage these incredibly complex trees with very simple code, and you can add new kinds of components later without breaking all the code you've already written, which is a huge win for scalability. But the main drawback, as we saw with that basketball app, is that sometimes that shared language is a bit too general, and it can force you to add methods that don't really make sense for every single object in your tree.
So, now that you can kind of see the world through this lens of leaves and composites, I'll leave you with this question. Think about the systems you work with every day, or even something like a family tree or a recipe's ingredient list. What are some of the complex hierarchies all around you that suddenly look a whole lot simpler now?